Hello, everyone. It's my pleasure to introduce this topic for you. It's my pleasure to propose this topic, to share this topic among ours. We propose the topic is the deep learning network for frequency offset cancellation in OFDM communication system. As we all know, the OFDM communication system nowadays is very popular. But there are more strong things in OFDM communication system. For example, the frequency offset is serious in this system, and the frequency offset destroys the algorithm subcarrier. So we post the deep learning network to solve this problem. As we all know, the deep learning network is also very popular in nowadays. Deep learning is proposed multi-layer to solve non-layer problem. The frequency offset cancellation is also the non-layer problem. So we proposed the deep learning network for solve the non-layer problem. Shuang and I together proposed the topic to you. In this presentation, there are 4 parts. The first part is the introduction. The second is the deep learning for frequency offset cancellation. The third is the simulation with bit error rate. The fourth is the conclusion. First is the introduction. For multi-user detection in OFDM link communication system, there are more interference. This interference is not only to frequency feeding of the multi-channel, but greater interference induced by the carrier frequency offset. The frequency offset is more serious for OFDM links communication. When the number of the subcarrier is determined, the frequency offset range is larger. When the frequency range is larger, the interference of multi-user access is more serious. Therefore, the access interference introduced by the interference of multi-user carrier frequency offset is the key for the detection of the OFDM communication system. This is more serious to communication system, especially for bit error rate. And another is also for multi-user detection. And the signal interference for multi-user detection is the frequency for the offset. convolution, there are more algorithms to solve this problem, but this algorithm is also means linear system. That means LS algorithm and MMSE algorithm is central. These algorithms are the nonlinear behavior, but these algorithms are linear behavior, so we can't solve this problem with linear methods and ML algorithm. The equation means the organizes cost function exhibits a strong nonlinear behavior, so we must find a more popular nonlinear behavior to solve this problem. So we select the deep learning network for frequency of sight. This means the nonlinear behavior. Therefore, a nonlinear width solution method based on deep learning network is proposed to solve the nonlinear problem. Nonlinear problem is the interference cancellation for OFDM communication. The OFDM communication system is seriously affected, both the transmitter and the receiver must know the Qingyang symbols. And in OFDM system, the Qingyang system, we can set the CP in this. So the deep learning network can iterate relative current through the Qingyang system. And the Qingyang system has optimum weight and can be used for frequency of sight cancellation. This is the basic idea for we proposed the basic important thing for we proposed this. That is to say, we can use the nonlinear behavior to solve this problem. This is the important behavior for we proposed the network. This is deep learning network for frequency cancellation. The OFDM transmitter means signal input and then modulation. Then we add in CP. CP is also the Qingyang symbols. We use the Qingyang symbols to chain the network. And then we get the DA conversion and up conversion. The signal can be transmitted through the multi-phasing channel. And in the receiver, we get into the down conversion and then AD conversion. We use the CP for train deep learning network. This is the important thing for we train the network. Then we get the demodulation and receive the signal. The key important is we propose the deep learning network for cancellation frequency of sight. This is mean we must first get the CP removal and then to get this chain the frequency of sight and use the deep learning network. This is the diagram for deep learning network for frequency of sight. And then we get the simulation. In nowadays, the BPSK modulation is popular, and we can use this modulation to train this training network. So assume the bit error rate of the OFDM is 40 bits per second, and this time the maximum relative carrier frequency is 0.35. And then we're using BPSK modulation. Each subcarrier in each OFDM can transmit 1 bit, and we set 240 subcarriers are required to meet with the transmission rate requirements. And more, we can edit CP for this and get FFT at the point of 256. And we also set the maximum frequency of sight and the bandwidth. So we set the parameters for the simulation on bit error rate. Why we use the bit error rate? Because we can set the transmit and the receiver for the comparison of the many algorithms. For example, we must set another algorithm. For example, LS algorithm and MMSE algorithm. And then we proposed deep learning network. We also set the frequency of sight is 0.05 and 0.35. There are two different frequency of sight. Use this sight, we can obtain the proposed deep learning network as more popular and more good, very good for this cancellation compared with LS algorithm and MMSE algorithm. This is because LS algorithm is non-linear solution for carrier frequency of sight and induced the noise. And MMSE algorithm also can get the important for cancellation. And we proposed the solution is very near to the ideal solution. So this is very important for detection multi-user. As well known, when the carrier frequency is small, and we use the frequency of sight BR as very serious to this. So we can get more the comparison for different. And this is the simulation result for this. We can get very bigger BER in nowadays and impact of noise enhancement. This is because the ICI and MUI can be deleted with our proposed the deep learning network. The last conclusion. In this paper, a deep learning network for OFDM is proposed. The frequency of sight can be limited before signal demodification. So we propose the nonlinear way that establish a deep learning network and form a system organization and maintains metrics through iteration. This is very behavioral in communication. And this is the main of our purpose. Thank you, everyone.